We are very happy to have Professor Balakrishnan with us today on the occasion of his retirement. We thought we'll have a conversation with him, talk to him about all the things that he's done and all the things that he plans to do. So, very briefly to introduce Professor Balakrishnan. Professor Balakrishnan graduated with a B in electrical engineering from Pillani in 1977. Joined IIT Delhi in CARE, the Center for Research in Applied Electronics, and got his PhD in electrical engineering in 1982. 82, is that correct? Sorry, 85. In 1985. And subsequently, he joined the computer science and engineering department after and had various stints in universities in different parts of the world. And he, as an assistant professor, he joined computer science and engineering in 1988, and subsequently has been associated with the department ever since. He has been the head of the department, and as he has been the head of the School of IT, at the institute level, he's been Dean of PG Studies, he's been Deputy Director of Faculty, Deputy Director of Strategy and Planning. He was also Vice Chancellor of Satyabharati University for a brief while. Bala is, of course, known for his research in computer systems, and over the last 10-15 years, his work in assistive technologies for handicapped people, in which he has made a great impact. There are many facts about Bala's life. We will not rehearse all of them now, but I'll go straight to Bala and ask him to tell us, where did it all begin? Where did you grow up? What was family life like for you growing up?
Yeah, so I actually grew up in Pillani. Okay, Pillani is a small town in Rajasthan. So I call it a two-horse town because there is one horse which is BITS Pillani, another horse is Siri Pillani. Okay, so my childhood was all filled with engineering and education, and because in Pillani didn't have anything actually. We had one rundown movie theater where you will actually get if the moon is if it's a full moon day, you can't see anything on the screen because half the theater was covered with tarpaulin, the other half was not covered. So if you are depending on the angle of the moon, what you see on the screen could be different. So really there are nothing there. Okay, so and my father worked in Siri Pillani, and I lived in the Siri campus, so which is one of the premier electronics institutions in the country. It's a CSIR lab, and so the childhood is all engineering. So it's all you mix with say scientists, your family, friends, people who come for dinner, they are scientists, people whom you visit are scientists. So it's a very sanitized, I would say, lifestyle that we had in Pillani. And of course, if you happen to cross the campus and go to the other campus, then you talk to people who are professors. Okay, so who are teaching, again, engineering was a strong subject in BITS, but they also have science and humanities and other departments. So this actually is what sort of gave me my, say if you really look upon it in terms of the career, I really did not have any other choice of careers. Okay, so either I had to be a scientist or I had to be an academician. So these are the only two, career choices known to me as I grew up.
So you decided to be a scientist and an academician. So basically, like electronics and so on was in your blood, essentially, at the growing up. And so then you got your BTech in electrical engineering, and then you decided to come to IIT Delhi for your PhD. How did you decide on this particular institution?
So that's also quite a coincidence. So actually, we had a very interesting. So because in Pillani everybody knows everybody, so it's a small town, that. So I was from the childhood, as you grow up in Pillani, your ambition is to go to BITS. Okay, so that's how the ambition gets set, and because the cutoffs are very high. High means, of course, high of those days, not of these days. Right. So, and not every child in Pillani will get into BITS because you just don't make it. They always had a very strict all India merit. There is no, though it's a private institution, but there are no hanky panky. We will draw a computerized list and cut off at whatever the number of seats that they need to admit. So very, very fair process. Very few institutions have that. And there are no issue of any money or anything. So when but my brother, who was 2 years senior to me, so he was persuaded. My uncle actually happened to work in IIT. Okay, so he was in IIT from 60s. So one of the very early employees in mechanical and workshop and so on. So he wanted both of us to get out of the house. So he was the only one in our family who studied in a hostel. So he said that you're all like frog in a well. And so you should not live in Pillani, you should go out of the house, because he studied in hostel. He valued hostel life a lot. But my brother wrote his JE and didn't make it. Okay, so, and he finally ended up studying pharmacy in BITS Pillani because he couldn't get the engineering cutoff. So he got into pharmacy and then So when I came to my higher secondary, those days were 11. So I also had to write JE. And the reason that for me was, I was expecting good marks to be able to get into BITS, but the issue was that there was a senior of mine in my school who actually fell sick on the board exam day, and he was running very high fever, and he spoiled his board exams just because he couldn't write at 103 degrees Fahrenheit, that fever that he was running on. So it was like, for us, the IIT was like a standby option. So, if what happens if I don't don't do my board. So it's very strange, a lot of people will think that and the only thing I had JE for preparation was the 3 years question paper, which my brother has bought when he was preparing. So this was the total preparation. His chemistry, maths, 3-year question papers. I prepared and actually I made it to JE. So I actually got some reasonably good rank. I wasn't getting electrical in IIT Delhi, but I could get mechanical. Like electrical was number 1 and mechanical was number 2 at IIT Delhi. I came for counseling. I was still not decided. My uncle persuading me to stay back and join IIT Delhi. But, one wouldn't believe, for me, the decision to go to Pillani was essentially based on the fact that it was much more cost effective for me to study in Pillani. The semester fee was same ₹100 at both IIT and BITS. And there I could stay at home, and here I had to pay some 95 rupees for hostel every month. So this made a huge this made a decision. And, coming to think of it, a very strange decision, because the year that we joined Pillani, they stopped assigned admissions. So we were all assigned into a whole batch of 500 students put into first year. And depending on your performance in first, second, and third year, first year, you could get anything from, everybody wanted a BE in electrical or electronics and electrical, or you could get an MA in economics or MA in English.
Wow.
This is the range of
that's quite a range.
based on your performance in the college. Okay. And I decided to take that risk rather than joining IIT Delhi mechanical engineering. It's the craziest decision, one would think that, but I made the decision. Of course, I did very well in my first, because you get the branch only after third year. After first year, the arts get separated, pharmacy and arts get separated. Second year, science and engineering get separated. And after third year, you actually get the branch that, very, very, very innovative system. 5 years they lasted. They stopped it after 5 years after we graduated.
too innovative for our country.
But it was a wonderful experience. So this happened, and my uncle was always so one decision was for me was very clear. I was very much bothered about the brain drain, and this was a very big debating thing at that time. Right. And I was very clear that I would not be applying abroad for my higher studies. Anyway, I had to become an academician or scientist. I had to study further. BTech was not enough. So I wanted to study in India. That was very clear to me. And the best option for me was to go to IIT Kanpur to do MTech in computer science. This was the most highest preferred option within the country, because computer science was available. Even ISC didn't have computer science, only Kanpur had it. So in between, my uncle actually said that because he wanted me to be in IIT Delhi at the time when I graduated. So he told me that there is this research position in care. If you are interested, you should apply. I applied and I sat in a selection committee interview in the old exhibition hall, where now the reading room has come.
Right.
And Professor Indiresan, who was heading care, he will only invite IIT students for top 10 IIT students from Kanpur, Kharagpur, Delhi. These are the people who will get invited for this selection.
Right.
I was invited just because I was number 1 in bits. Okay, so they invited me. So it was a fairly psychological experience when they circulated the sheet and everybody had to write which institute they were and what their CGPA was and what their rank was. Okay, so getting a research assistant position was so tough. Okay. So I made it, and then I said, okay, it was very early. I got my offer in middle of sort of April, and I graduated in mid-May 1977. And 2 weeks break, I said, okay, my interview in IIT Kanpur is only in July, sometime late in July. So let me go and join and see how does this research position looks like. Whether so I was not at all clear that this is very attractive. I didn't have any idea what this care means and what does the research position mean. So I joined on 31st May 1977, just 2 weeks after my graduation. And then, and the lab was so good and people were so good that I never went to the interview at IIT Kanpur. So I just stayed back next 45 years. So,
wow, and that was like 45 years almost. Right? Tell us a little bit about Professor Indiresan. What was it like working for him at the time?
To me, I would say that in terms of policies, in terms of his views on education, views on IITs. So a phrase that I always remember and which has made a huge impact on me, he says that there is something wrong in this country. We import Mercedes cars, but export those who can make it.
Right.
This was, so this particular sentence said so many things about our system that we are not able to retain talent. Those of you who are sort of familiar with my work at IIT, so I would say that most of my effort has been in this direction. How do we retain talent? Okay, so whether we created flexibility in academics, we created better scholarships, better opportunities for PhD students, everything, I would say that if in one nutshell, what has been the focus and objective of my work is essentially derived from this particular statement of Professor Indiresan, which made a huge impact on me in terms of, why are we not able to retain talent, which can actually make a difference. And he retained talent. I can tell you, I do not think in India, anybody could build a research group of the quality that he built in care. All my seniors were toppers from either IIT Delhi or IIT Kharagpur. Of course, Professor Anshul Kumar, many of you may know who are our own alumni. So Anshul was a gold medalist from IIT Delhi, who was my senior and who was my first contact, first mentor, who taught me many things about digital design, about testing circuits and so on. So I was in such a august company, in terms of learning and in terms of camaraderie, in terms of just brilliance, in terms of their understanding. When those of you who know Professor Prasad, like he was one of the toppers from IIT Kharagpur, who also made
Professor Surendra Prasad. Yes.
And those days were familiar with JEE. The first cutoff for JEE was electronics at IIT Kharagpur. Okay, that position, once the CS and all came, that position they lost, and CS department started getting. But electronics at Kharagpur was one of the top programs in the country, and he was one of the toppers from that program. We had Professor Dilip Shahani, who later on became a professor in IDC. He was a topper from IIT Kharagpur. We had so many. Professor Rajendra Bahal was one of the toppers from IIT Kharagpur in electronics. IIT Delhi, we had so many. We had Sheila Aditya, was a professor later in electrical, and then in NTU at Singapore. Then so many. All these 10, 12 people who are senior to me in that group, they all had excellent credentials, and they were, So, and the lab was very well funded. So that's very important because of the fact that Professor Indiresan had a huge sort of respect especially in the defense community. He had a huge respect. And the funding was not a challenge. We were the best equipped lab in the institute. And we used to get absolutely the top students of electrical would come and work with us on their projects. So although I was myself, let's say, a junior project scientist, I have guided top students, and and they obviously did great work because they were very motivated, and many of them ended up in today top positions. Some of you may have heard of somebody like Paul Raj. Of course, Paul Raj left before I joined, but Paul Raj was a PhD at INCARE. He did his PhD with. So this is the quality, who could go and set up at Stanford. He could get a professor's position and set up his own successful startups. So it's a very great environment, and these people are all, in some sense, Professor Prasad was a. So, but Indiresan's attitude towards education, Indiresan's attitude towards society, though technically I worked with him only for 2 years because he left in '79 to become the director at IIT Madras. So 77 to 79 was a direct when he was my boss. But these 2 years, and later, of course, we kept on engagement even as when we were in IIT Madras, and then later on through various other connections, I had maintained that contact with him till he passed away some time back. But he has been a great influence in terms of, and of course, Anshul has been a great influence in terms of technical, grounding and many of the other aspects that technical.
Right. So I think this is something that, many of the people who are watching this interview may not have had the opportunity of meeting Professor Indiresan or knowing much about him, but he was clearly an influential figure in the technology community, and he groomed people like yourself and many others to take on leadership positions. And I think a lot of the leadership qualities that you displayed or you developed over a period of time came from his approach and his thinking and the way he went around building institutions. So although I was thinking of asking about institution building later on in this discussion, but since you mentioned Professor Indiresan, I want to ask you this question first. That so you have been in leadership roles. You were a Dean PG, where you tried to incorporate new ideas to get talent and maintain it in the institute. Then you were a deputy director of faculty, which is of course all about getting and retaining the best talent, because faculty makes an institute. And then also a DD strategy and planning, which again goes in the same direction. And to some extent, for some time when the Satya Bharati plan was still underway, you had an opportunity to, in a greenfield setting, create an institution from scratch. So you have worked on developing an institution which was already there and creating a new institution. So tell us, how has your thinking changed from that time when you first came into leadership roles, say as a head of CSE, to now? How has your thinking evolved? What can you tell us about building institutions in India?
You see, the way the thinking evolved is initially when you are growing up, let's say when I did not have a leadership position, I'd say till I became the head, okay, you do not understand what are the challenges in terms of priorities. You understand you need good faculty, you need good students, you need good resources. Okay, this, of course, everybody who is thinking about an institution understands that these are the three important things that are required, because if you don't have good faculty and you don't have good students. But the challenges are, first of all, what is the most important? In a different settings, it will become very different in terms of when you have branded institutions. For example, I would say for first 40 years, 45 years, IITs didn't really have any competition in getting excellent undergraduate students. Let's say 99.9% of the Indians couldn't afford to study abroad, and and I personally believe that geographically, brilliance, or whatever you call it, intellectual capacity is geographically distributed. It's not like one country has all the bright people, another country has all the dumb people. It's not like that. There are brilliant people everywhere, in every community, in every issue is whether people have the opportunity to hone that skill and come to a level of getting into a very good higher education institution. So when IITs didn't have a competition in terms of getting the best, especially at the undergraduate level, of course at postgraduate level we always had competition, primarily because you could get fellowships and go abroad. People who are good, then you didn't have to financially support yourself for studying abroad. at postgraduate level. But undergraduate level, most Indians couldn't afford to go abroad. They couldn't even think of, going abroad. So if they had to have, they will naturally come to us. So this is as a situation in IITs which lasted for a very long time. Unfortunately, it is changing now with affluence growing and people having options to go. So the challenges are, so at that time, the challenges was clearly, and when computer science started becoming important, and the importance has continuously grown and is going to grow even further in the next 10 years. If people can't see that, it will be very unfortunate. And which means that the faculty in computer science, we are going to have competition. And we also see a very strange competition from industry, which doesn't happen in many other engineering disciplines, even in many science disciplines. So when you have decided, a person makes a decision to be in academics when a person joins PhD in many disciplines. But that's not true in computer science. We still have an option of going to industry, not just industrial research, but also in industrial development. So there are a lot more opportunities for, for a computer science PhD, which means that you have to become more attractive even for those graduates who may otherwise want to actually look at industry options. And of course, issue is globally there is a dearth of talent, and global dearth of talent means you have competition for global. So once they became ahead, it became much more clearer that it's very important to focus on faculty. So that was one thing that was. Other thing I noticed, because of all the exposure that one started having with people coming from outside, and you're also traveling for various institutions abroad. One thing it became very clearer that we are very dogmatic, we are very conservative in terms of giving options to students. And some other things that you mentioned, industry also in favor, people mentioned. So this was something that I tried to break the barrier. My point was, maybe there's only 2 undergraduate students who want to do an MTech here. Why don't we give even those 2 students an option to convert them to, for whatever reasons? There could be 100 reasons why a person want to continue in an IIT. Many of my faculty colleagues, even some of my deans said, "Oh no, which IIT student want to do an MTech? Why would he convert?" I said, you create an option. And today we are seeing that there are people who are actually switching from some disciplines to some other disciplines for their masters, and that's happening because we created that provision. Okay? Yeah. So we don't have to. We think in terms of whenever we think of some policy. So creating those flexibilities, whether it is. So the other thing first thing was faculty, and that has remained, in across disciplines and more so in computer science. The challenge of getting the top quality faculty is going to be, and when the areas become hot, like AI and ML is very hot. So obviously, so one advantage that institutions like IITs have, because we have followed a very flexible recruitment approach, where we are open to recruiting people from abroad in terms of even, with online interviews, and they don't have to be present themselves as a selection committee. So I have tried to work towards increasing that flexibility so that we are able to get the best person at the time when they want, because now we have rolling advertisements. It's not that I created it, but once the opportunity, I saw this is happening in one IIT, we pushed it and we could get it done here. So increasing flexibility to be able to recruit the top quality faculty has been one priority. Then once I became Dean Postgraduate Studies, so it was very clear that we had to focus on. Of course, it was very clear before, but I didn't have any instruments to do that. The policy has to be to make our PhD positions attractive. So one of the things that I could push through was budget for students to travel to conferences, international conferences, because before that, hardly any provision was there for a PhD student to go for international conferences. So we created those type of provisions so that they get both an exposure, and also these things make attractive. So a person says that, oh, I'm stuck here, I can't see, anything outside. Third thing that became more obvious, and that started happening little later, is in terms of resources. Okay, so because we are a government institution, and we only have, typically, most of the institute is only bothered about spending. Spending is made complex, so that whatever money gets, even to spend that money becomes very difficult for most of the institution. And so there is no focus on how do we raise resources. The whole focus remains on how do we actually spend whatever the government gives. And what if it gives more, it's fine. If it gives less, it's fine. So that is another challenge that I said in the flexible resource generation, which actually gives you the type of flexibility to be able to do things which government is not comfortable to spend on, has been the third priority. And these three, I would say in that order, faculty being the first, PhD students being the second, and this resource generation, flexible resource generation, which helps the institution to be able to competitive. And the fourth thing, which has recently emerged, I would say in almost 10 years, is that we have to also revamp our image to attract undergraduate students. Okay, because of the very large
exodus. There's a competition now. So yeah, these are good points in general. I think institutions across the country or those institutions that are starting up to look at. I want to change the conversation now because I'm being a computer scientist myself. I'm interested in understanding. You made the transition from electronics, a place like CARE, which was very much about developing devices, electronics, which went into systems, and from there you made the transition into computing. So tell us a little bit about that transition from electronics towards computing devices and computing systems.
So so as far as my actual work, so when I did my PhD, I did it part-time, and it was really part-time. Okay, so in the sense that I spent maybe 50 hours per week on my project and 10 hours per week on my PhD. Okay? So I'm not very proud of my PhD. Okay, let me be very because I just didn't spend that type of time. My projects were exciting, and we were developing top of the line systems, and we were the fact that we were taking it to the field, putting it on ships, testing them. So it was very exciting work and very rewarding in terms of satisfaction. But my PhD supervisor, so IIT Delhi didn't have a computer science engineering department. The closest, so there was a small group in mathematics, but there was a bigger group in electrical engineering. Okay. Even Professor PCP Bhatt, who was, let's say, the first PhD to be, he was the second to graduate, but first computer science engineering PhD, you can say, with Professor Rajaraman at IIT Kanpur, was Professor Bhatt. He was the first to register, but Ibrahim Shah, I think, completed a little bit earlier, and he completed a little bit later. And these were the early PhDs from India, and they were, Professor Bhatt was my supervisor, almost by default. Because Anshul was such a big mentor. So Anshul was registered with Professor Bhatt, so I didn't think anything, and I just got registered with Professor PCP Bhatt. Okay, and then later on, Professor Madan was. So my work in terms of my PhD was actually a fair amount of CAD work. So I was actually, basically you can say that the compilers generate assembly code, but I was generating microcode. Okay, so I was assembling algorithms into microcode. So I was writing algorithms not at the intermediate level, at what we call a register transfer level. And so these are the type of tools later on became very much part of today. They are part of the industry, but these were very much part of the development at that time. So my PhD, I was already dabbling into computer science. So I was understanding compilers, I was understanding operating systems. So I did a course in operating systems. So though I was actually on ground, I was, what I was doing on my 9-to-5 job was actually designing digital systems. So So this was a sort of a transition period, and then it so happened that the postdocs and all my places that I went, so they are computer science departments. Okay, and so my transition, so I developed into EDA and CAD. So I made a complete transition from. So I was still, my tools were still designing hardware. So I had this advantage that I had an excellent idea of what is an efficient hardware, because I was a designer. So this was the advantage I had. I was not very good at the CS part of it, but I was good at the part of it, that the output that it has to produce, how should it look like to be an efficient hardware. Okay, so this is how my CAD work happened, and even some of the better quoted cited work of mine in terms of synthesis and so on. So because most of my early work was in synthesis, and we were fortunate that we were in, and this was, I would say, credit all due to Professor Anshul. So if Anshul had published more out of his thesis, so I think we would have been, as a department, would have been known even 30, 40 years back, because his work was contemporary to what was happening at CMU.
Right.
As good or bad, not better, more abstract than CMU. Okay,
Right.
and only a couple of institutions in Germany, couple of institutions in US, and one in Japan. These are only 4 or 5 institutions which were at a level at which we were doing hardware design at that time. Okay, so.
Right.
And then, of course, when I came back, I decided to come back to computer science engineering department, primarily because of, not because I really enjoyed my days in care, but it was very clear to me in the later part of it, after Professor Indiresan left, it was very clear to me that in IIT, it is very important to get a faculty designation and not a scientific designation. You don't get the same autonomy if you have a scientist, and it's the type of autonomy you get when you have a faculty. And so, and Professor Bhatt had moved to computer science. And just to add, when I was almost like 6 months before submitting my thesis, they asked me whether you want to get your degree from computer science or you want to get it from electrical engineering. Because both my supervisors were actually moved to computer science, Professor Bhatt and Bala. So, the distinction between electrical and computer science was so narrow that, if I just wanted just one application, and my registration would have moved to computer science. But I thought, I had registered for so many years, 5 years in electrical. Why should I move just for submitting my thesis? So I just got my degree from electrical.
So, on the basis of what you're saying, I just want to ask you a different question. So it appears to me that the work you did at that time could be called interdisciplinary. Your grounding was in digital systems, and you had to learn computing, you had to learn compilers, programming, and so on to be able to make the interface. Would you say that it was in that context of that time it would be called
the EDA area is, so if you look at the EDA area, so it is actually people like us who have dominated the EDA area, because the EDA developed, CAD and EDA actually developed at that time. Almost, I would say, 9. So very few people from mathematics are into EDA, because you have to have an understanding of the digital systems which mathematicians don't have. You see, computer science, basically, either the mathematicians move to CS or electrical engineering move to CS.
Sure.
But if you look at this domain, it is actually and if you even look at its main conferences, for example, DAC was the main conference. For very long, it was a joint conference of ACM and IEEE. Okay, so many of the major, of course, now the transactions have all become different, but there were community which was actually at this ACM and IEEE actually globally decided this particular EDA growth. So if you look up on it, it's a very interesting area in one way. It pushed, see, today things have changed, all this web and cloud and everything, because your databases have become very big and things like that. So there is a lot of, but all the top, whether it is data structures or whether it is efficient algorithms, they were all for EDA work. If you look at starting from 70s, 80s, 90s, and up to, let's say, mid-90s.
That's true.
The most complex systems that software was designing was actually chips. Because by late 90s, your complexity of a microprocessor has already crossed few million gates. And you can imagine on a chip which is around 2 square centimeters, you have to actually put a few million gates. So, this is what we teach in EDA courses, that we show a particular chip. It is the size of a city of Delhi, if you consider the houses. But only the total size is 2 square centimeters.
That's right.
Everything. So all the complexity of software actually went into the top people. Of course, these things have today changed, because you have, Aadhaar databases, and you have even millions and millions of, and Twitter feeds, and all these things have become very large.
Complex.
But that was not the case. So EDA actually, in some sense, also pushed the actual applications of data structures and algorithms in computer science. So that way, but you will find even today, if you go to a, let's say, top EDA venue, you will find 85% of the people would have a basic electronics background, senior people especially, and 15% would have a CS background. So that remained, that remains true.
Right. That's very interesting, actually, to think that algorithms and software were driven, of course, by the hardware. And in fact, even today, that happens to be the case. And maybe even the databases, cloud, and all the device design below
Just the
those is
volume.
very
See,
important.
the point
The
is,
volume.
a
The
tape out,
volume, simply
for
the
example,
volume.
a
Right.
tape out, previously a tape
Right.
out of a complex chip would actually take weeks.
That's right.
Your design is ready. You just have to write onto a magnetic tape. So you will see, the leading players were 3 people, and all 3 of them have top EDA groups. In software, what do you think of? You think of Bell Labs, you think of Watson, you think of Philips.
Right.
These are the 3 guys who did, who drove computer science. Okay. And later on, Xerox PARC and so on. So they came from a slightly different. But even Xerox PARC, if you look at the early Xerox PARC work, it's a lot of EDA because they had to make their photocopiers, but they were ASIC chips. So the design and all these software application of software. Of course, there were people who are doing compilers and so on and so forth, which was slightly different. Later on, only these compilers merged into it, and we were the people who started doing it because we started compiling into hardware. Okay, so when we started doing synthesis, we were compiling code into algorithms into hardware. But actually, people who are doing designs, they had to place these transistors, and these transistors are what today it's 10 nanometer transistors, and analyze power, analyze everything. All of these are extremely complex pieces of algorithms and software. So there is a lot of let's say drive to software. Need for efficient software came from EDA in the VLSI design.
Right. So you worked for a long time at these the intersections from electronics. You came to hardware, software interactions, and so on. You did a lot of fundamental work in that area, and then at some point, I think about 15 years ago, you moved to this. You opened out this area of assistive technologies in IIT Delhi. So tell us a little bit about how that started. What was your thinking in getting into that work?
See, I would say I think all of us go through midlife crisis. Okay, in some ways. Okay, so what happened was the 77 to 85 when I worked in CARE, I was building systems and we were installing systems. And I think I should mention, for example, one thing we are very proud of is I installed myself along with the naval officer a system on INS Vikrant, which helped aircrafts to land on INS Vikrant, and which actually saw service for many years before Vikrant got the old Vikrant. Now, of course,
the old Vikrant, the previous, the original Vikrant. Yeah.
So I actually have stayed in a pilot's cabin in Vikrant for 2 weeks installing that system.
That's amazing.
Of course, the Vikrant was in dry docks. It was not sailing. It was for major refit. It was coming from Bombay. So this was one period. Then I went into EDA and so regular research, publishing, software. So all of this. So where you clearly are making incremental contributions. There is no today things are much better, in the sense that we have at least a lot of EDA companies in the country. But when we started in the 80s, there was nothing. There's no company. There's neither not even a VLSI design company. They forget about fabrication. So we were doing. So there was always this feeling that what we are doing is something incremental to a global effort. Yes, the standards are always set by where you publish and so on. So then a chance meeting. So one day, Mr. Dipendra Manocha, who is actually a blind person, he happened to walk into my office and referred to by my uncle I mentioned to you earlier, who was, so these two were friends in terms of exchanging music cassettes. Dipen Manocha is also a music buff, and my uncle was also a music buff. Okay, so they were exchanging cassettes and on some basis, some interval. And Dipen Manocha asked Mr. Swaminathan was his name, and he asked him, can you refer to me somebody in the computer science department, who can help me in this Emacs? So he was using this Emacs editor, and Emacs is not compatible to screen readers. Can somebody help me making this Emacs editor compatible to screen readers? And as my uncle knew me well, I was not doing any software. I was not doing anything, this type. So he just said, my nephew works there, why don't you go and meet him? Okay.
Right.
Then Dipen Manocha, accompanied by somebody, comes to my lab and he leaves me, and that was a turning point. Okay. So what was impressive about him was he has actually only training in music. He did his BA in music, then he did his MA in music. He could sing a little bit. And then he registered for PhD in music in Delhi University. But after 6 months, he said, I'm not learning anything. He left. Okay. And then he joined, started working with computers, learned computers. And you can imagine, and he had set up a Linux setup in National Association of Blind. And he was running that Linux setup in, So, those days, open source software, Linux are not so friendly to install. You had, of course, you didn't have to write scripts, but you still have to sort of get access to those scripts and you have to download them, configure them, So this is, I'm talking about in, early 2000. Okay. So, more than 20 years back. So then, so this is why when he invited me, I visited him and so I said, okay, I don't work in this area, but we have smart students, so I can always get some smart students because students are always running around for projects. So I got a couple of students to work on this Emacs editor. Okay. And they did some good job. They could, get some interface done with their screen reader software and things like that. This is how our association started. At some points, I was acting only as a channel agent. He will pose some problems. I will not hardly be involved in it because that was not my area of research or my area of work. But I will still get some students who could write software and sort of put them in touch, and we will somehow mentor the students to get something. First 2-3 years went like that, and then he came up with this idea of the smart game. He said that this is a problem. We have obstacles which projects and we get hit, and I said, yeah, this is something I understand. Now I can, this is, you need a hardware device, you need some software on this device. So by the time we already made a transition, so I was dabbling in embedded systems also, not just EDA, because that was a natural growth. Embedded science had come, and we were doing a lot of microprocessor work. And I had also started this very interesting COP 315 that later on became that, where I had to give projects. So I'm always looking for anybody who had some ideas to give me some new ideas for giving projects. Okay. So I said, yeah, this is something I will float. And then fortunately, it was the Rohan's batch, okay, where, so they all joined and I posed the problem to them saying that, we have this problem and can we design a small device for, both. We started on both the bus device, the onboard, which we call it, and the smart kids, both of them. And, the type of commitment Rohan and his group showed, the rest is history. So, so then, so we worked on it for 3 years, many models. And in between, we ran into Professor Madhusudan Rao because we had to do a rapid prototyping of our design. And the only rapid prototyping setup in the early 2000 available was in Professor Madhusudan Rao's lab. And he was so enthusiastic that he got into the project. We were only wanting to use his facility. He started giving his own ideas of how the design should be done. And then, we built a very nice team, which actually ended up into a very successful project. And then, of course, we have continued, and it was, in some sense, my background of care sort of, in some sense, got activated because this was something which was reaching the users. We were talking to the users, and so, it was a very much more a satisfying experience for me to be able to go back and do something which actually reaches the users. And with the cooperation and the way the team built, so I started slowly. Of course, still I had some people, 1 or 2 PhD students still in the embedded area, but mostly I started shifting my focus from guiding students and taking projects in embedded to. And then another transformation happened. So initially it was only embedded systems projects for visually impaired. That was the focus. And once we got into it, and once we started traveling, once we started meeting more and more organizations within India, outside, then it became a passion that we should holistically look into the problem. After all, we live in IIT, where there is all types of expertise available and you can collaborate. So, so then we did this tactile project where Prem Kalra helped a lot. We got in touch with him, and, whatever we couldn't do, he could pitch in because there were graphics into it. So that way, now it has become that we look at holistically at the problem of education and mobility of the blind, irrespective of what we have to do to be able to solve that problem. Okay, it is not software, hardware, embedded, because and these are very practical problems. You do not always require that you have to push the state of the knowledge in software or anything, or in algorithms. Even using existing algorithms to solve this problem will be good enough. These are not commercially attractive globally, so talent is not going into solving these problems. And countries like India, we have a huge challenge. Our number of people are so large. Whereas other places, the number of people are very few who have this, handicaps or this type of disabilities. So either they don't have solutions. Even if they have solutions, they are so expensive because they are produced for a small number of people. Right, so we are the natural place to do research. So there is no way we can say that it's not an advantage to do research.
So your work with assistive technologies was very successful. You won the Eugene Lawler Prize given by ACM, numerous prizes, and a lot of recognition has come your way and the way of your lab and collaborators over that. The question that I have is, what are the general lessons that come from this? I mean, one thing that it appears to me is that there you need to make a successful technology play the way you did. You have to have a certain kind of technological depth, but you also have to be willing to go out and look for the real problems that need solutions out there, where there is a need, and you have to marry what you know with what is needed, which may often mean that you have to go beyond where you already are, learn new things, and to be able to build the solutions.
Yes, what you're saying is true. So basically, you look upon it. This is actually to do with users. Okay, so you are not a user. You cannot judge what is the need of a blind person. Let's say if you are a student, you know how students behave, and to some extent. Okay, so you can talk about, so let's say if you look at the story of Facebook and things like that, it would have been hard for a non-student to design Facebook than a student to design Facebook, because of the fact that you are actually in that ecosystem. So now in our case, because we are all sighted, all the people who, so it was very important that we get linked to the users. And this was where the Dipendra Manocha not only played a role, because he also has been with organizations. It's not that he is the only person. He has been in National Association of Blind. So we had easy access. Our students could go and meet this, test it, get the ideas vetted, and so on. So that was one thing. And later, once we started becoming a bigger group, we also were very clear that it has to be very interdisciplinary. Computer science is just one small part of it. Mechanical engineering is a big part. Design is a big part. Users is a big part. So I think now, of course, with pandemic, things are not unfortunately the same, but we were perhaps globally the only lab where we had blind people sitting along with mechanical engineers, the design engineers, and the computer scientists, all within one roof. Okay, electrical engineers. So we had all these five very different skilled people sitting in the same lab and working together to develop solutions. So that is made a huge difference in the way we were thinking. Because there are lots of things which I have large number of anecdotes which I can tell, which can prove that they just have different abilities. It's not like they are disabled. Okay. Sure, because there are so many things which they can do. So if your design can exploit those, let's say for example audio cue, which our onboard exploits. The reason the onboard was very successful in trials is much harder for a sighted person to hear a sound and get a direction. It's very easy for a blind person to get a direction, because your brain actually gets programmed in a way that the direction is found by getting the audio signal. Okay? And we are not using that that much, in our day-to-day, because we can always look around and find which direction sound is coming from, who is speaking or who. So this was a very big sort of an achievement in terms of creating such an interdisciplinary group, which is important when you are working in spaces with which you are not you're not yourself the user.
I mean,
I would say
so
that.
if you had to pull out one or two general principles and give a couple of lines of general advice to a young technologist who wants to start up, make an impact, a young faculty member, a young graduate, what are the general principles that you have learned from the assistive technologies work that you would give them?
So I think, see, generally it's a little bit of a, I would say, temperament issue also. As I said, that the fact that I so when I came to IIT Delhi, I was fresh. Okay, I just had a graduate degree. I can't even claim that I was very good at lab. I was very good in mathematics. I was very good in logic. I topped all my maths and even engineering courses. There are a lot of mathematics. I topped all of them. I topped programming. I topped logic courses. But I was not really good in the lab. So if you really say that design, many more students in my electrical engineering batch were much better in the lab than I was. But then I got trained in this care, under people, as I told you, very bright people. And so it was, so you can put two things together, and when you put logic together with testing, you can learn testing very fast. So, but the fact that I got, my temperament was that I was not getting the same satisfaction in publishing papers in the EDA that I got by my Assistech, and I got from my earlier work in, it's just the way that I got programmed in my young years when I was just out of college in those first 7-8 years. So that has played a big role. I cannot say it is true for every person. Okay, so your training, you may get a kick out of getting a paper in a top conference, and that may be the kick that you get because perhaps you haven't been exposed to something else. But then that's it. The chance, this is how the life goes. So I would say that. But the fact is that there are a lot of, I would say what would be satisfying to many more people is impact. Okay, so one is, impact is in terms of impact factors, of the journals and so on. So that's one type. Another type of impact is if the work that you are doing actually get used. It could be used by an industry, great. You're doing a technology transfer, So I think a lot more people, at least at a certain stage in life, it may be. Unfortunately, we also gone into a system where career progression is very much linked to publications and top venues, and that requires a lot of hard work. Keeping up with, especially if I see areas like ML and Vision, every 6 months a new conference completely defines what benchmarks you have to achieve in your papers. So very, very competitive, So, but once you are past that stage, once you feel that if you are getting a kick out of it till the age that you are working, that's fine. But if you are not getting a kick, I think you should seriously look into areas where you can. And there are all types of interdisciplinary areas, whether you apply it in agriculture, but my point is, don't apply peripherally, go down and talk to people. Let's say if it's in agriculture, both talk to the farmers and talk to the agriculture scientists. And that I would say that last few years, what had happened in IIT Delhi is great. I would say, I'll give though in some sense I was responsible for getting the AIMS collaboration happening, but afterwards ICAR, NPL, today we are linked to all the, NCR is a very rich place in terms of institutions. There are a lot of expertise in all areas, and all of these people are today looking for collaboration with computer scientists because things like AI and ML. And if you can make the next, find a right time to put pesticide just by doing, right time to put how much fertilizer, all of these can make a huge impact on people's lives. Okay, so in terms of efficiency, economics. So I won't say everybody has to work in assistive technology, but I think there are all areas, economics, the same situation, weather prediction, the same situation. Everywhere there are so much of work to be done where computer scientists can be involved. I would suggest that those people who think that, yes, whatever fundamental contribution to CS they have done is not going to satisfy them further, they should look for strong tie-ups with practitioners of other disciplines. And it's a great opportunity for a computer scientist to do.
So I want to take the conversation now. I think we've been talking for some time. A few things I want to ask you about the people in your life. So we talked about Professor Indiresan, we talked about Professor Anshul Kumar, what a mentor he was, and Professor Bhatt, others, so many others. Uh, Tell us about the students that you have met over the years. All students, I know, alumni, think remember you very affectionately and all that. Tell us about some memorable students. What have you learned from your students over the years?
Yeah, so I know, unfortunately, I'm not a good person in remembering names. As a teacher, it's bad, So I know people like Professor Bhatt can remember names of, many generations of students. I'm not good at it. But, there are many students who have made a huge difference. Okay, so some of them, Rohan, I already talked to you about because of the dedication, the whole team, the Rohan, Vaibhav, and Ankush, and, all these people who are together who started up this Smart Cane, and, they really were focused and led by Rohan, and clearly they made a huge difference. Sharad Malik, for example, who was a student when I was still in care. Okay, he was an electrical engineering student. I was not a professor. I was a scientist in care, but he did his project with me and Anshu. Okay. And days, for example, in 80s and early 90s, we couldn't afford to even buy conference proceedings. We just couldn't afford, nobody
Right.
afforded. So he will get conference proceedings from US and ship it to us. Princeton would always have spare copies. Okay, Berkeley would have spare copies because he did his PhD at Berkeley. Berkeley is at the forefront of EDA at those days, so people, even his supervisor is a huge star,
Right.
In EDA. So he was so committed to the department, to us, I would say, to the EDA group, and that I don't know whether you were still there, maybe you're not still there. So we had a standing sort of a thing that if he is going to take sabbatical, he has to come to IIT Delhi.
Right.
And so he spent a year, both he and Aarti spent a year as a visiting faculty in computer science department in 96, 97, I think, 97, 98.
Right.
And they changed the direction of the group. Their 1 year presence of Sharad, actually, we made the transformation from an EDA to embedded systems, primarily because of the mentorship that Sharad gave. Because, see, as I told you, because we were still following, okay, so the Indian industry is not leading. So we can't get the same problems. And none of the young faculty can imagine traveling abroad was like, you have to do a 6 months tapasya. Really travel abroad, So, one slot in the department, and you will get a princely sum of 14,000 rupees. Rest of the money you have to beg, borrow from DSP. You have to travel. So we won't even send papers to conferences because it's useless, because you travel to. So that was the time when I talked about. So when, so the fact that the EDA world is actually getting into embedded, we were not seeing that the big picture. His presence here.
Sharad's presence changed.
So Sharad came here and we wrote a big proposal. We got funding on that proposal. He mentored students, and and we learned a lot of new things that were happening. How compiler was getting integrated because embedded was coming. So all these compilers, which are efficient compilation techniques, which can, though they are still generating software, but they know more about hardware than the previous compilers knew, because previous compilers would only stop at assembly. They only had to know the assembly instructions and they could compile. But so these are the type of things that we are very sort of let's say these are, and there are many students, I would say. Of course, the PhD students are those I remember, fortunately. So people like Anup Gangwar and Basant Dwivedi, because it was a time when even the theory group at Khandekar, and so we had this half a dozen PhD students who changed the image of the PhD in the department. Undergraduate students were scared of the PhD students.
Right.
Otherwise, before that, the undergraduate students had a very poor opinion of MTech and PhD students. But when Anup Gangwar, Basant, Khandekar, these people were TAs and they will make them work. And Anup was actually an electronics BTech and a VDTT MTech. Actually, was a TA for compiler courses, operating system courses, and he understood compilers better than CS students, undergraduate students. So, so these students actually were, made a huge difference, and the fact that they had a good overlap with Sharad helped, of course, there are numerous students. So so of course, the VLSI EDA group was very popular with top students, I would say only till around late 90s. Then, the more and more things were, people are more interested in going to networks earlier. And then, of course, now this all AIML. So we are just users of AIML, but we are not the drivers in terms of science.
Right.
So those changes happened. But, even though the great point of students coming to the lab may not be great, but I have found them to be very competent. It's just that they don't have the opportunity to show. So I have never bothered about taking a student based on what their academic performance is. As long as the only thing I want is the person should be sincere, and I think our students are still brilliant enough that they can deliver on what we want if they just get focused. The problem is they may not get focused. That is the more challenge than their academic performance.
So I have just two questions left. So I can see behind your shoulder, there's I think the 60 years of IIT Delhi logo. So 45 is 75% of 60, right? So in 60 years of IIT Delhi's life, 75% you have spent with IIT Delhi. So tell us something about IIT Delhi, about your experience in general terms at this, 45-year mark or so. What has IIT Delhi meant for you? What does it mean to you today?
No, IIT Delhi has, whatever I am, it's because of IIT Delhi. Okay, so I give full credit to IIT Delhi. Various places, starting from KR 1977. Of course, 85 to 88, I was not here. I think IIT Delhi provided me a lot of opportunities. Whether as a scientist, when I was in KSET, it's a very well equipped lab. We could, I could order almost anything. Take a catalog and order it, and it will come. Of course, there are a lot of, unfortunately, those regulations are again coming in scary. But I think you have to get some clearances, not manufactured in India. Because import was difficult, but we had no shortage of funds. We could be at the cutting edge of technology as possible in a country like India. So there was And when I came back, yes, resources were much less. I think the 90s was the worst period in my view for IITs. Starting the liberalization 91, 92, when it started, the liberalization to 97, 98. The 7-8 years was the worst period in terms of funding for IITs. Government froze funding, and so everybody was only doing some simulation work because nobody could afford to do anything else in running some simulators. 98 again. So by the time IITs got recognized, so I give credit to this 2020 program, which put IIT is equal to Harvard plus MIT plus Princeton or something. So it put that, and US it became a big thing, and US started this IIT, and then just like I always say that Indians realized the importance of Ravi Shankar only after he played with them.
With the Beatles,
he played with Harrison.
Exactly.
So the Indian students realized it. They were still fighting to get into IIT, but the politicians and the administrators did not realize that we have such a
the American news show CBS.
So then, of course, the funding has actually been going up. So 97, 98 onwards, we have been in an upward swing, and along with the pay commissions, which actually gave more importance to faculty. I was part of the struggles, so some of you may be aware, I was represented Faculty Federation twice in the negotiations with the government. So this, all of this essentially has helped us in terms of, I would say struggle is much more because suddenly the society wants us to be internationally competitive. This is a big change, okay? Because nobody wanted us to be, we were, whatever you call it, top of the dung heap, that was fine. So now it is no longer the same. So now you have to be internationally competitive. It's a big challenge for our administrators and for the next generation of IITs, because you will lose the sheen if you are not able to compete globally. So that is where the focus has to be, and at least government has been supportive in terms of this Institution of Eminence program that is actually giving us some funding, and they have relaxed foreign students and so on. But we have to still to be very innovative. Our resources are much more limited. And whatever said and done, we are also living in an economy which is, clearly still an economy which is far away from developed countries. So there is going to be a struggle, but I think the future is bright as long as we have the vision and we have the support of the government, and they give us the autonomy that is required. My only wish is that sooner than that IITs get what IIMs have got.
Right.
It will be a big
Right.
change. Okay, so
Thanks, Bala. All right, Bala. So I think we've talked for a long time. Your throat is also getting dry. So I want to conclude the interview. There is still many things to talk about. There so many details that we have glossed over, like, for example, your critical period with critical and the development of a startup out of IIT Delhi. There are many things, but time is relatively limited, so we can't talk about all of them. So I want to just thank you for all of your contribution to IIT Delhi. We are lucky we still have you with us. You're going to be here with us for some time, and our students and alumni and your colleagues can work with you, learn from you, and you can continue to mentor all of us. And while we have the opportunity and seeing what is Bala going to do next, and where is the excitement going to take you next, is something we all look forward to. So thanks a lot for talking to us today, and all best wishes always from all of us.
thank you, Amitabh, for this opportunity to talk. Thanks.